and welcome to the panel discussion number 2. Uh, the first instruction we received was that you have 10 minutes less than what was originally allotted to you. So, yeah, I guess we have a challenge. You are lucky. Yeah. Okay. The title of our session is Human-Cobot Collaboration, Issues of Job Creation and Skilling for Skilling with Robots. So it's a slight mishmash of two topics, but I have a very versatile and eminent panel with me, so I'm counting on them to see me through, right? So I don't know, all timings are off, so we will see how it goes. I'm just going to quickly make 2 points as my opening remarks, and then I will pass it on to my colleagues here on the panel. Opening remarks, and then we will start the discussion. I think the Cobot, as I understand it, and for the purposes of this discussion, I'm taking it as yeah, and one of the promises of robots and also cobots has been the flexibility that they bring, to the workspace. Unfortunately, I think that the big robots never delivered on that promise because they still need jigs and elaborate programming up front, for them to even start production. So one of the things that I believe cobots have a role to play, at least in the context of India, is that there is a possibility that they can allow you to tune the scale of production, right, to the demand that you want to cater to. Right? Typically, what happens is that for most products, the technology is frozen by what is practiced in the West. And those are driven by volumes which are in the millions. While India has billions of people, but it's a very fragmented market. Right? And so it's very unlikely that in most products of some complication, right, you will see a large enough market to justify investments in these kind of devices, especially for the small and medium enterprise. So that's one thing that intrigues me, and I hope that we will get some time to talk about that, is that what role cobots can play in providing that flexibility, of matching the scale to the market available for a particular product. So people in the literature and the business refer to this as high mix, low volume production, right? So I'll be curious to understand from any of my panel members as to what the challenges are in ensuring that cobots can actually deliver on that promise of enabling, this kind of high mix, agile, low volume kind of production. The other point, and that has to do with skilling, is this debate that has been right there with us from the morning between, automation and assistance, right? I come from the school that the robots or the cobots must play a larger role in assisting than in automating. But I hear different voices from my industry colleagues, and I do defer to their views. But nevertheless, again, going back to this number of people that we have, I think that is a question that we cannot neglect, so lightly, right? It has to be taken very seriously. So one of the things that I want to put forth is that can we use, the inherent nature of cobots, the ease of programming that everybody promises, and, the collaborative, facility with humans in the environment for skilling, right? So I see it as a two-way process. One, can we use cobots to improve the skills of the human operators, right? And two, can we, develop technology that downgrades the kind of skills that you need to program and use these cobots, right? One of the things that practitioners mention quite often is that, you don't want a robot to replace the need for looking for highly skilled welders with the need for looking for highly skilled robot programmers, right? So the need for skilled, labor does not go away just because you have a robot. It just that it changes the nature of that. And therefore, skilling does not go away. And I think that it might be useful to think a little bit about this problem of, can we use, cobots to train people, removing tremor in their hands when they do welding, right? Or any other such task that we can think of. And B, can we develop technology that makes interacting with a cobot much easier? Therefore, the skill that is needed to operate that also comes down, and therefore opens up opportunities for a much larger population of people than it is possible today. So that's what I would like to open with. Start from my left hand here. Remarks. I'm not going to pose a question to him, but feel free to make remarks.
Thank you. Thank you, Professor Gurumurthy. It's a pleasure to be part of this eminent panel. Maybe a couple of open remarks from my side. If you look at the world today, there's a lot of transformation which is currently happening, irrespective of the domain which you come from. If you have to talk about 8 such transformation, certainly one is everything has become autonomous, automated. Yeah. Yesterday I was pleasantly surprised when I went in for a Zara showroom in Forum. I was really surprised, pleasantly surprised to see a automated checkout system where you can bill on your own. You need not have a dependency on the uh, person on the other side trying to scan those cards. Yeah, which we have seen in only the airports and some airports and globally where you can do a check-in process. Here, that was really good. Second is connected living. I think there's a lot of consumers who use many different services to experience compelling new services with a combination of video, data, audio. Yeah. Then third such one is certainly Industry 5.0. Already we are talking about Industry 4.0. World is moving about Industry 5.0 with more of human automated collaborations. And the fourth is digital reality. So there's a lot of things which are happening, be it in the augmented world or the virtual world. There's a mix of digital world into the virtual world. And sixth is heterogeneous society. This society is remaining no more homogeneous. So this society is moving towards heterogeneous data. How do we capitalize on the data? And the seventh one is sort of a Uberization, sharing of assets. Today, you don't depend really to own an asset. And the last one is some sort of concept called zero defect, zero cyber attacks, zero accidents, zero fatalities, you name, every industry is talking about zero. These are the 8 different trends, I would say, shaping every single industry in this world. So with that as a background, I think we have an apt subject. So how do we capitalize on this automation? Yeah. When you talk about Industry 4.0, for me, the definition of Industry 4.0 is getting the visibility of material flow in the system. So if you are able to get that visibility of material flow with that data, you can do lot many things. You can become much more efficient. And that's where once you have that, the application of cobots or the virtual reality or the use of automated guided vehicles, all this comes into picture. So make use of the data and use this assisted function so that you become much more efficient. At the end of the day, I think India, as an industry, we have to move from cost arbitrage to performance excellence and also being much more competitive in terms of the cost. We cannot continue to depend on labor dependency. I think we have to move towards this thing. And that has to start from leadership. Actually, we as a leadership, we are driving this new initiatives within this company. That would be my opening. Right. Yes. Yeah.
Hello. So good afternoon or good evening, everyone. Actually, if we look at the manufacturing, only hardly 8 to 10% of the processes are automated. So there's a lot of scope for automation, enhancing automation in manufacturing. And when we are talking about smart manufacturing, the aim is actually to make manufacturing CES. Now, what is CES? Cost efficient, effective, safe, and security. So we want to have these functions in manufacturing. Now, looking at our country as such, India has this unique characteristic. We have 63 million MSMEs, and 99% of the MSMEs employ less than 10 people. So the challenge is, how can you bring in automation? How can you bring in robotics into this MSME structure? And MSME you cannot ignore, because that's the backbone of our industry. Almost 40% of the output is coming from MSME. Now, if an MSME has to adopt automation or usage of robots, he must see a distinct advantage in it. So if we look at, like, our topic of discussion is this human-robot collaboration. So in which ways can the robots collaborate with humans? Either we can have processes where robots and humans are coexisting, each one is doing their own work, or you have processes where it is a cooperation between humans and robots. Robots are performing the task and human is supervising the task. Or you come into the third factor of collaboration, where the robot is working closely or collaborating with the humans. So in a way, it is helping to aid the human. Now, why would we require this human-machine collaboration? Now, I would refer to the 5 Ds that are there, which will give the advantage for tasks which are dull and repetitive, for tasks which are dangerous, for tasks which are dirty, where you have polluting tasks. Also, one more D, let me just come to it. Yeah, for the tasks which are difficult in nature. Especially we heard in the session about automotive industry. Now in automotive industry, or if you look at, for example, the steel industry or the metallurgy industry, you have dangerous metal, hot metal. So that is where it would work in. And now the 5th D is a little bit of the impact of the pandemic, where you are looking for distance among people. So when these 5 Ds are covered up, I think the combination of robot and human works well. Now, of course, as we heard in the discussion before, can India, being a populous country, would it lead to job losses? No, I think, as Honorable Chair also mentioned, Professor mentioned, that actually we are going to see a transformation happening. The jobs will transform themselves, and you will see job enhancement happening. So the mundane jobs, the repetitive jobs can be done by the cobot, and the humans would need to go a notch higher, the supervisory. I think that is, in a way, it will also give better utilization to our human power or human skill that is there. And I think in such a scenario, you will have a good combination of the cobot and the human working together in a collaborative manner. Yeah, that would be my say.
Yes. Try yours and see if it works. Yeah, you can switch it off.
Yeah, hello. I think it's not. Okay. Okay. So thank you very much for making me part of this wonderful panel. It's a pleasure, and thanks the audienceship. Now, we just heard about 5 Ds. I'll talk about 3 Cs. So one C, so C, cobots are collaborative robots, right? Now, what are the 3 characteristics of collaboration? And I'm just trying to make up the 3 C's out here. One is you have to cooperate with the humans on the shop floor. You have got to counter sometimes. Sometimes your colleague is unreasonable. You have to come up with a rationale. and say, so it's not always cooperation. Sometimes it is a counter. And finally, when you are done with this, in this whole process, you have got to communicate. You have got to somehow get your views heard to your colleague, and you have got to get the views back from the colleague. Now, when I'm talking about a cobot, I'm talking about a robot and a human being working as colleagues on the shop floor. And the robot, today, if you see most of the robots, and as beautifully said by Rajesh and by Prashant, that they have to be safe, they have to be competitive, price competitive, and of course, you expect them to do what they're expected to do. But robots of tomorrow are going to be intelligent. They're going to be smart. They will have their minds of their own. That's where artificial intelligence comes. First, we human beings program the robots. Then we human beings teach the robots how to look at the data. The next thing the robots do, they start collecting the data themselves, and they get smarter and smarter. And then finally comes the wonderful thing that Professor Gurumurthy was talking about, the robots teaching it back to the humans. And now, if you look at it, this is already happening in Florida. The surgeons, they cannot move their hands completely, right? I mean, there is a human wrist can only go that much. But the robots, that can go all 360 degree. So they can do the sutures and the surgery, the sewing much better. And now that they have learned it, they are actually trying to teach the humans what is the best way they can do with given the constraints that they have at that wrist. So cobots, absolutely the future of tomorrow. Robots with emotions, robots which are learning, most importantly, robots which are connected and which are intelligent. Now, with that, we'd love to, defer to my colleague, to my co-panelist.
This works, so I take it. So I need to have my slides in there, and I have the automatic flashing thing. Hopefully it works. So which way did it move now? Okay, now numbers. So I don't know if you know about Anton Exupéry wrote a book called The Little Prince, and the airport in Lyon is named after him, World War I ace pilot. So he lamented that adults always want numbers. So this is his quote. I'm also an adult. I think we are all adults. So I'll give you some numbers. So the human machine is a 200-watt machine as an energy source. If you put him to work over 8 hours, he's going to produce 0.2 into 1 kilowatt into 8, 1.6 kilowatt hour of energy, which is 1.6 units of energy in terms of electricity. 16 rupees if you're an industry, right? Domestic, much less. And if you're unfortunate enough to be a solar power supplier, then you'll get only rupees 4 for that amount of energy that you put in over a 8-hour cycle. Okay. So even if you look at our minimum wages, we actually pay that for cognition. It is not for the energy that a human being puts in. And certainly minimum wage in the US, India is 350 rupees, somewhere there. US is 3,000 rupees. So that is paid for cognition. So we have cognition going around. Otherwise, we would not have the lifestyle that we have even in India today. So this is the first point which I want to make. The second thing is we want to leverage either the flexibility of human cognition to simplify the interaction for the robot. That's one option. And then we replace biological energy with electromechanical energy. That's a simple solution. Others, we try to add as much flexibility to cognition into the robot system to simplify the interaction for the human. So you enable labor with lesser skills to work on it so that the labor is bored, might be sleeping off, but the robot will keep on working, occasional poke. right? After all, we all know that humans don't like to think. So that's the second thing. Now, the question I think which is here is, going forward, do we pick the low-hanging fruits, which is just pumping the energy into the system, make it easier for humans, or we try to make it easier for humans by not asking them to think? So the second one, I think, is a difficult proposition we need to look at. So this is called Human and Robots on an Assembly Line Van Gogh style, because I typed this into Bing Create and it created this picture. Okay. In fact, the earlier picture was also from Bing Create. So Bing Create is very good at making this picture. But the reality is, even now, automated production is fully automated. Sequences carried out exclusively by industrial robots, or there are full manual assembly steps where humans worked on allied tasks. Close collaboration is extremely limited and usually not possible, right? And over the last decade, these what are called serial compliance robots are available, KUKA, LBR, then there are the Barrett robots, and then now there are several more. They're around and they promise that, even if you go into it, it will not push you, it will stop. All of that is programmable. The tech is there, right? So you heard Professor Ramesh Babu, I think even Guru Murthy were around. Yes, they can be made. Question is, will they be economically worth it? So we are here today, perhaps because we have become significantly better at integrating abilities of perception, navigation, all this stuff into decision making and learning. So we are at a threshold where we can build robots that interact with people in more flexible ways, right? So you have Google Maps, it can decide how to go from here to the airport, but you still need the driver. Driving a car which is, largely automated inside, right? Temperature control, you can have, but you still need the human being to avoid the crashes. So we can have robots to coexist, right? Side by side, no shared workspaces, sequential collaboration, not the same part at the same time, same part at the same time, which is cooperation, and then responsive collaboration. You learn from each other, right? Progressively, a robot is getting better and better, watching a human being sees how the robot does it, and he just mentioned you learn from the robot. This is a better way to do that. So all of that is possible. So the catch is, I'll come back to the German part later. So there's a classic example of a car seat to be assembled. So this is a classic paper in our areas. So you see that seat, and then you see on the left-hand side, there's a plate that had 4 bolts, right, 25 millimeter diameter. Well, screw and the hole have slightly different diameter. We call it a tolerance. Keep that. But when you put it in there, there's a problem. So you have to jiggle the seat around to make it fit into the sheet because there are 4 holes. It's only much later that they realized that the better design is having 1 hole, which is 25 millimeter, and a slot, which you see on the right-hand side bottom, and then 2 more holes, which are oversized. So this can be assembled uniquely and does not require skill on part of the operator to jiggle around. So finally, when you do this, it is this seat which is robot ready. Not the earlier seat version with 4 holes in it, which are the same tolerance between the pin and the hole. So why did I put this across? Now, this part means, it's a very famous saying by Hilbert, which says, we must know and we will know. And inconsistency, somewhere in the second paragraph, and unknown are 2 greatest enemies of robotics. You can do cognition, but if you have inconsistency and you don't know, you cannot do robotics. And now this is the phenomenon, is that our undergraduate education, at least in mechanical engineering, is almost completely focused on building components and manufacturing components. So in the years to come, as an academician, I want to tell out to this full community that we need to rethink a little bit so that We deal in terms of assemblies so that we can actually relax the component manufacturing tolerances, but we can build a full system which performs better than the system with the hard tolerances. So this is the call. There has to be some re-education so that it comes in, and then we have to rethink the way we design the products and make the products to make this collaboration possible. So that's what I have. So, well, there's much more. Thanks, limited. Thanks. You're welcome.
One doesn't, yeah, it seems to work. Yeah, actually, following up on what Sudipto talked about, Dan Whitney at MIT Draper Labs, he had once written an article titled "Real Robots Don't Need Jigs, but Who Needs Real Robots Anyways?" Right? And the tenor was exactly the same, you know, and that's why I remembered that paper, which was that, you know, if you ask students to design a robot for washing plates, right? They will go into all kinds of circus trying to, you know, find grippers and graspers and fingers to apply to hold the plates, to apply the soap and push it under the water, turn it around, and then, you know, stack it. But then the real solution, of course, is an airtight compartment where you can actually hit it with water so hot that human hands cannot handle, but the plates get cleaned, right? And so that's something what he is also talking about. And I guess I'm trying to find a way to weave it into the conversation that we were intended to have, and I'm still struggling. So let me not take that point further, but I just want to go back and ask, you know, one question from Rajesh Nath, and this, I think Menon had also mentioned it in his in the previous panel, the role of, you know, associations in getting companies, especially SMEs, to adapt new technologies, and Cobot being one. So I was just wondering if you have any thoughts and any examples from your VDMA experience. Yeah.
Thank you for the question, Professor Gurumurthy. I think certainly the role of an association. What is an association? Association, in a way, is something like an aggregator. There are various companies, members of the association. So association actually plays the role of a networking platform. So you can have the association can certainly play an important role, especially when we are talking about new technologies coming in, giving awareness, especially in this case, like I can also, Professor Gurumurthy, I can give some examples, concrete examples. Like as VDMA, we have done we did about 4 events on smart manufacturing in various cities across India. We did recently 2 events related to OPC UA, Open Platform Communication, which is very important. So the whole aim of this was, in a way, to educate the industry, especially what we heard also partly in the first panel about Industry 4.0. Now, there is a misconception that Industry 4.0 is something like a black box. It's very tough to adopt. Now, there are certain aspects. So what we've tried to really bring forth to the industry is that there are certain components or low-hanging fruits, what you can actually adopt. Even the MSME can adopt that because the cost factor is not very high. For example, let's look at remote monitoring or condition monitoring. Now, actually, if a machine breaks down, the MSME is more impacted than a larger company. The larger company has deep pockets. He can withstand perhaps 5-6 days or 1 week, but a MSME cannot withstand more than 1 or 2 days of a breakdown. So using simple tools like condition monitoring, remote monitoring, if you get real-time data, you're able to assess the real-time data and take remedial action. So if bearing temperature is getting higher, you have the data, you can change the bearing rather than wait for the machine to break down. So these are certain simple measures that even the MSMEs can take. And I think for MSME, it is important that the ROI, he gets a quick ROI. Now here you're not investing big amounts, you're using simple methods, and the ROI for the MSME in this way, he can really reduce the ROI. Similarly, when we talk about the cobots, for example, now one of the advantages of the cobo is that the cost effectiveness of the cobots. They are not very costly as, let's say, a traditional robot. They're flexible. You can move them around. If you're changing your manufacturing or changing the product line, as was mentioned earlier also, you can surely move the cobot from, it can be mounted on a table, you can move the cobot. And plus, I'm a very firm believer that actually cobots give a lot of opportunity for women. Women can really start working on the cobots because it is not very complex also, and we, especially in the tier 2 rural areas, I think this really gives a good opportunity. And as we know, Mr. Mittal is also here, we need to have more women coming into our workforce. And I think there are some statistics that say if we can get more women coming into the workforce, there's a possibility that GDP can increase by 1.5%. So I think this is a really a good advantage to get more women employed in the workforce in India, and especially in the smaller towns where the work opportunities are also limited. So these are the advantages I'm seeing, and this is where I think a little bit of education is required to the industry, especially to the MSMEs, that utilize technology. Because as an MSME, there are certainly a lot of apprehension, cost factor, then they are not very confident now if they adopt something, whether they will have the manpower available or trained manpower for automation. So this is the message that should go to the MSME also, that, and it is imperative, we need to move the next level up. We cannot be at the same level. If we are talking of our country, we are looking to increase our export. We are looking also to how India can add to the global value chain. You can only add to the global value chain when you are making products of better quality, more efficient, your whole processes are more efficient. And for that, you need to adopt automation, a certain level or certain degree of automation. And this should be right across the board. Of course, the larger companies can do it easily, but it is the MSME who really needs to get that confidence to adopt automation.
Thank you. Yeah. So to both my colleagues from industry, just building on this, the fact that cobots have some advantages. Both of you, I figure, are fairly large companies, right? But I'm sure you must be having vendors that supply into you. So I would like to have both the perspectives. You as a large company and your vendors' shoes, if you were to travel for a minute. Where do you think cobots applications really lie? What kind of tasks they lie? And second, in terms of improvements in cobots as future features and future improvements in technology, what do you expect? What do you want?
Thank you. We started this Industry 4 journey about 6 years back. And after reaching certain level of maturity in terms of data acquisition, then we slowly started enhancing the implementation of the adjacent technology, one such as Cobo. We are into automotive, we do a lot of electronic embedded products. Today, if you see in our Bangalore facility, we have in excess of about 20 Cobos. And it works out very well. Today, for ROI is less than 3 years. Because a universal robo costs you about 18 lakhs. And with the increase in the wages, what you factor in, and more so, you also started seeing attrition in the blue collars, especially in the advanced industries. So how do you negate this? I think this is one area which we have found, and globally, continental users in excess of 5,000 Cobos. Wherever there is a repetitive in nature, or with our sharp products, or which are hot in nature or intricate fastening systems, we started implementing Cobos, and it has been very, very successful. And the best part is when a human is working, then you have to factor many other things. Whereas when the Cobo is there, you need not factor. So to that extent, it's becoming efficient. So this has been our journey, and we continue to see where the opportunities are to keep implementing on the Cobos.
Going forward, where do you see the opportunities and what kind of improvements or changes you wish to see?
So certainly, I think one is today's challenge is designing of grippers. Still, we see a bit of a challenge there because every design is different there are no common grippers. So that's one. And second is, and also when it comes to India, the service supportability. I think that's one area. I think all this, I'm sure with the number of Kobo implementations going up, I'm sure they will be able to go. But today, that's the challenge. So what we have done is we have invested upfront in terms of training our own engineers so that we don't rely on the service providers if there is a breakdown. Because when you are using a Kobo in assembly, and if the Kobo breaks down, the entire assembly shuts down. In the sense, you'll not be able to do. So that's one of the challenge we saw, and today we are able to cope up with that.
Sure. And Prashant, you stole my words. So all that you said, I fully agree with you. And on top of that, there's just a couple of things I'd love to add. So more and more smartness, more and more that intelligence that we talked about, because India we have fantastic digital talent. We have a lot of AI, ML, that kind of thing happening. So how can we get these things, get these components, the overall systems get smarter? And we work on that. And the second thing is, and that is exactly what our clients also expect. Like, for example, we have a project going on in a place called Pilabara in Australia. This is a 168-mile railway line for an iron ore company, Rio Tinto. And Rio Tinto's, like from dumpers, truckers, they put that iron ore on those trains and ship it to the port. These trains are completely automated, auto rail. They are driverless. Now, of course, you can do that in Australia where there is hardly any people. You try doing that in a junction here in Bangalore. You have to have a game theory engine probably embedded because everybody is negotiating who is going to go first, right? So this is not going to be tough. But nevertheless, this is what our clients expect. As a Hitachi, as a global company, how are we transforming the overall landscape, getting better, getting smarter? And naturally, we expect the same from our downstream supply chain. So smarter components, smarter people to work with, that keeps us going.
Silko, to come back to you, I have a slightly different question. If I can get this on. This is what it's already good. So one of the things that we've been hearing both from here in this panel and in the previous panel was that there are two problems right now in India, despite the large number of people that we have, is that one, for the jobs you need, people are not there, and that is true both in rural areas and in the urban areas, it looks like, right? Agricultural labor, the skilled varieties is not there, and industrial labor also is not there. That's one. And the other one, of course, is the cost. I think he just mentioned that the costs are also, becoming a little skewed in terms of the economics of the whole operations. So given that, and the fact that you have to do something with these people, who are otherwise not, being able to enter the market or jobs in manufacturing, how can you use, cobots for skilling? Anything. Just to sort of throw this thing at you, I was more thinking in terms of like exoskeletons, for say welding, right? Like a gripper that acts like steadier for traverse and train them to follow a line or a curve or things like that. Just a wild thought on my part, but your thoughts on can it be used for training?
Yeah. So I mean, I'm part of a driving training simulators, right? So you sell them. So what we realize is you can teach some skills through these kind of trainers. It's possible. And yes, it needs a level of intelligence to be built into it to give you the impression that it is reacting to what you're trying to do. So that is a learning element, which is there. And so they can be used for training. But at the same time, the operator is always aware that it's an artificial environment. So when you work with these kind of systems, cobots or anything which has artificial intelligence, human senses it and refuses to learn lots of things from the system. So you can pick up, but not all of it. So that's my take on it. So empathy. So I mean, the human being realizes very early that that system doesn't have empathy, and it's kind of like a pushback.
Okay.
So I don't know.
Well, some, yeah. But I think see the organizer standing there asking wrap up. But so I'm just going to throw one question, at each of you. I would wrap up, right? There's no secret. And then last comes, something. Yeah. So one quick word from each of you, either on, what India can do to become a manufacturer of cobots. You mentioned a price point that an international vendor was offering. I think in the previous panel, there were a couple of companies that were manufacturing them. I don't know if they match this price or not, but if we have to be a big player in cobots, making of cobots and selling of cobots, what we need to do, that is one question. The other question is this whole skilling question that, India needs to skill at scale, right? Unlike AI and, Python and, other tools, this can't be done online. Right? You have to have the feel of the machine in your hands, and you have to be in a lab, right? So how do you train the millions of people coming out, effectively? So either question, both of you, 1 minute each.
Actually, a couple of things. As a company, what we have done is we started about 4 years back something called Software Academy. We were finding it really difficult, especially these Gen Zs and the millennials, for them to make them sit inside a classroom and teach them. They will never learn. So how do you digitize some of their learnings where they can do on a go? So this is one which has been very, very helpful. Today we have a lot more than in excess of 600 plus course curriculum, so which they can learn at their own speed, at their own at their own time. So that is one which has helped in upskilling, reskilling, to some extent unskilling also. Second one is industry. I think industry alone cannot do this. So we need to have this partnership with academia. So that's where we are also cooperating with some of the universities, where unfortunately in the industry, what happens, we'll never be able to solve all the problems. There are certain problems which will be left behind because of time. So what we are trying to do is those problems we are getting to universities where they can work and come with the solutions, which is being a win-win situation. Through this, we are able to address many challenges. Number 3, I think today, manufacturing contributes about 16% GDP to India's GDP, and the target is to reach about 26%. I think if you have to really read that, I think we have to put more goods into the system, so there has to be more consumption. And if that consumption has to happen, then it has to be affordable. If it has to be affordable, then you should be able to produce products at a much competitive prices. I think that's where this automation comes into play. I think this is more of a front loading. Still, I'm sure today 85% of the manufacturing GDP is from MSMEs. Whatever the big industries does, that's only 15% contribution, but I think this has to start at the grassroots level. That's why I was talking about this starts with a leadership, where you have to do a front loading, where you should be able to see the picture 3-4 years down the line. Don't look at today. So.
Yeah, I'll take from what Prashant said. I think looking at your question, Professor Gurumurthy, about manufacturing of robots or cobots in India, I think it has to be a harmonious play between, we have the industry on one side, we have the research R&D institutions, and of course, I would like to add academia and the startups also here. I think startups can also play a important role. Now, what is the advantage of startups? Startups are much more flexible, agile, I would say. Smaller setups, they can undertake projects, as Prashant said. There are some projects, larger companies may perhaps take a little longer, but then working together with the startups, they can find a solution. So it has to be it has to be all 4 factors. It's part of the ecosystem if we need. And perhaps another thought would be, which I would, maybe the government can look at also. We have PLI schemes in various fields. Maybe a PLI scheme for the future could be on robots or cobots manufacturing in India, because if we are able to attract this manufacturing, and I think especially for cobots, it's a big untapped market. We've just started using cobots and very few manufacturers are there. So it's a huge potential, and especially considering our MSME structure. So if the MSMEs can start adopting, if there is incentive given from the government, either direct or indirect, as was discussed earlier, whether the MSME gets the incentive if they are utilizing cobots or some level of automation, I think India can become a important hub for manufacturing of cobots. But it has to be supported by the government, and also we have to see how this whole ecosystem, at the moment, I think there are some loopholes. So we need to plug in these loopholes so that it becomes a harmonious play between all these stakeholders.
Very quickly, on top of adding to what has been said before, the upskilling part, let's take it. One wonderful way of skilling up, skilling, at a mass scale could be augmented reality and virtual reality. That is see a lot of promise. It is still in infancy, but I think people who do not have direct access, at least at some level, we can give. And of course, there is the 3D manufacturing with the next generation, learning things, how physics and mechanics work in real life. We can create some replicas, and the other part is how do you make this is a much tougher question, but there are two thoughts. One is probably it will help us to have an icon. Like in Finland when Nokia was there, the entire telco industry, it exploded. And probably we need more encouragement and funding, like the way MHI is doing for PLI, for startup. Knows no bounds. So we should encourage our young people to invest more time in understanding mechanical engineering, electronics, mechatronics, as opposed to getting the next job in Goldman Sachs as an investment banker. So these are the two things that come up.
Okay, so this works. So okay, working. So I used to be a skilled batsman. I could cover drive because I had done that 1,000 times. I don't put my finger into the burner because my mother told me so. Right, so that's education. So the issue is especially with cobots, we don't have them. It's a future technology. We have to understand that we have to educate. It cannot be a question of skilling. And we have to raise levels of people so that they start believing when we give them the data. So we need a set of people who believe in numbers, who understand that, yes, there will be some glitches, and that variability is something that we have to live with. We all do it. When I came here today, I didn't know what this dais would look like, but I knew that I could push a view across. So all of this is possible because we embrace the uncertainty. So that's different paradigm of thinking, and classically it is supposed that when we go through our education system, we learn these things. So instead of skilling, which is practicing and expecting that we have to be future ready. So yes, it needs a attitude change also in our approach towards employing people and the training that we impart to them. We tell them, yes, there are these uncertainties, embrace it. It will happen. There will be some glitches. Embrace it. It will happen. And then take it forward. Very drastic, but.
Oh, unfortunately. Oh. Okay, so I'm sorry I don't have, because this instruction said close by 4:50. And we are 5 minutes ahead, so I don't have time for questions from all of you to the panel. I hope there will be another opportunity for us to engage, but I would like to take this opportunity to first thank the organizers for giving us this opportunity, and to my wonderful panel for sharing their thoughts and views so patiently. Thank you all very much. Huh? I can take one or two questions? Okay, so before you clap. There is no take break. Oh, so at the cost of tea, yeah, we can ask some questions. So please go ahead. Yeah. Yeah. So questions from the audience, please. Or any member in the panel. Yeah. There's one there. Yes. Yeah.
I'm Dr. Rajan. You can hear me. Nothing Motors. No, I think they can hear.
It's good. You go ahead and use it. Yeah.
Is good?
Yeah.
All right. So I think at different levels, the scaling has to happen at the managerial level, at the operator level, etc. So anyway, before I go to the question, thanks to the Ministry of Heavy Industries, CMTI to organize such a the ecosystem starts here right now, as we have already started doing that. So Athi Motors, we are OEM making autonomous mobile robot. Professor Yogendra Narasimha had come. He mentioned about you. One time the customer, German customer came and said that, I want these things. He didn't say auto rickshaw, he said tuk-tuk. I'll take the person, 2 days, I'll give training, after that I'll put him. Your machine should run. If there is something changed, you know what to change, and then it should go. The ease of use, at the end of the day, people forget technology. People forget product. Whether it can be trained and put onto deployment and use. That makes that the most important thing. So at the lowermost level, that kind of a training. And then for ROI, etc., where the managers, kind of operating managers do that, they need to understand whether this all can be deployed, etc. At the highest level, I think when we go for large scale things, can we take that decision? Is it capable of doing it? At different levels, the trainings are required, just not, all have to be in sync with each other. Otherwise, top management may think that, fine, we can do that. When you deploy, then you think, no, this is not working. Oh, this is working, I want that. So I think skilling at different levels is what we need to think, right from whether a diploma or ITI person, we take it and we can train that. Or from an engineering perspective, they also want to know about it. They're busy with production, but they also want to know about it. But at the decision-making level, they also want to know what kind of a thing, real-time analysis, condition-based monitoring. I just want to know where our, OEE or uptime thinks of, why things you couldn't do it? Or can we really scale up how the automation is working? So everywhere, the level of training differs. So that we need to identify and do that. Then I think we can find the right ecosystem partners too. So observation is that skilling is must at different levels. Ministry is, Mr. Vijay is, keenly listening to it, and panelists have, without any doubt mentioned time and again that's requirement. So I think we'll start doing it. Thank you.